Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're gonna talk about how ESA lost its wing. So let's dive deep into it. So let's get some context, historical context. So it was founded, the foundation laid was in 1958, basically just after Sputnik shock. Basically, Sputnik not only shocked USA, it also shocked Europe, because you have to understand from their point of view, that boom happened very next to them. So they were very in shock, so to say. So they started some options, and the option was ELDO, European Launcher Development Organization. Basically, these people were responsible for making rockets. Then they made ISRO. And yes, it sounds like ISRO, but it's ISRO. So European Space Research Organization. So they launched the first puppy in 1962 and second one in 1964. I'm talking about the organization. And they were merged eventually. So what you see now as in ESA, that puppy was created in 1975. So that was the final form that you see today was forged in 1975. So it has 22 major nations meaning member nation, that are directly 24 into 7 into them, and there are extra nation involved also, like Canada. So they do have some serious financial backing. And then on top of that, they have 2,200 employees, which primarily use English and French, which I found odd, but given the population, it kind of makes sense. And they do have some auxiliary support for German systems, because again, there are a lot of engineering work done in Germany, and some Italian support also. But the primary languages generally English and French. So this is the history of it. So that's how they started. So how they perform? Well, their launches were named Ariane series. So Ariane series was first launch happened in 1979. It was surprisingly successful, and they launched it from Curios, French Guiana. Now this puppy. Now you may be like, okay, this is South Africa, this is India, this is Europe, this is USA. Why the heck it's next to Brazil? French does have a colony that is still French colony. So French Guiana. So basically they went to here. It's almost uninhabited. You can look into map. It's like barely inhabited. So they developed there. Is there a benefit? Yes. It's very close to equator, meaning if they were launching it to, let's say, a rocket from polar orbit, basically pole, North Pole, or basically here somewhere, this versus this is around 500 meter per second. That's how much delta V they're gonna gain from launching here. There is only one country that can have like a desired oomph that will be directly on equator. So is it a very big deal? In the early days of rocketry, absolutely. Not today anymore. We have more oomph, but nowadays it simply means if you are launching your rocket from, let's say, Texas here, somewhere here, you launch from here, it means you have a bit more leeway, a bit more oomph. You can have much better boost back burn, those sort of things. So not a very important thing, but early days it was very important. Early days it was like shut up, take money. So that happened. Ariane 1 to 5 were made, and they were successfully used, and they were retired. As of now, when I'm making this video, either the last one is on launchpad or done, like the end, retired. And they have a very great track record. This is another interesting part of them. Like, they were very cautious, they very thorough with their stuff, and it paid off. Like early days of basically Soviet Union and USA, they were going all out. They were going balls to the walls. Benefit development, consequence, their track record was like very sloppy at the early days. They had genuinely good track record from day one. So it was like not amazing, like, whoa, how the heck they did it. It was like, I see what you're doing. Like, there was a reason to go to them. And they are genuinely focused on geo performance. And benefit of that is because of the closeness to equator. If you are requiring every ounce of oomph from your rocket to go to geostationary, that extra boot can directly translate into you launching a 6 ton to 650 tons. 650, I'm saying 6 ton to 6.5 ton, that sort of things happen. So they really focused on geostationary, and it paid off. Right now, as of me making this video, they only have Vega rocket left. Now Vega, to give you some context of it, think of it as ISRO's PSLV rocket. It's a small satellite launch vehicle. So it's working. That's the only thing they have, because again, Ariane 5 is retired and Ariane 6 is behind schedule. It's supposed to be ready by 2020. You are reasonably sure that you are watching this video in 2023 or 2024, and the best optimistic hope is that actual payload delivery would happen mid of 2024, maybe a bit later than that. So it's behind schedule. So do they have any manned aspiration? Yes, they have manned aspiration. SUSIE. So SUSIE is this puppy. Now this is basically miniature space shuttle. Now I'm like, why miniature? Well, reality was space shuttle was basically forced into this world. It's not supposed to be. The two parents that was there, basically NASA was parent number one and armed forces was parent number two. They did not make love properly. So armed forces like, we want our biggest satellite to be launched from this. It's like, why? You can just launch it on a normal rocket. The payload bay was unnecessarily huge, and you were like, oh, it allowed bigger thing. No, it backfired badly, like really badly. So this time they're like, hey, what if you actually need to launch a big payload? Launch it on top of a rocket. We're gonna carry humans and some auxiliary equipment, which will be more than good enough, and again, more than enough for small satellites and all that. So that's it. The end. They're not trying to make everything. They're just like, hey, and it will be directly launched on top of a rocket. So it will be much more stable and does have emergency abort system. Now, benefit of having this sort of track record is this puppy. This puppy is one of the single most expensive non-living thing there, as in $10 billion. So James Webb Space Telescope, and they only could have trusted it to something that is absolutely awesome, absolutely reliable, which is basically Ariane 5 at that point in time. So be mindful. This is what they have earned so far, that you trust their name. So this is how they started. Surprisingly successful. So what happened if everything was nice? What happened? Well, in the early days, they noticed a very big gap in the market. That is, in USA and USSR, both were focused on national interest, meaning if their governments, they were busy spying on each other. So they were going all out, balls to the wall in terms of national tools. They were not paying attention to private players. Now you may be like, isn't Europe destroyed at this point in time? Well, yes, but it also led to a boom where like everything, like the money growth that happened after World War II was like almost miraculous. It went from everything is destroyed to dun, dun, dun. So they had a lot of private players, and so did America. So there was a lot of private players, but they were not being catered to. So if they went to USA and they're like, hey, I want to launch something, it was like, yeah, wait 5 years. Or wait times were that bad in the early days. They went to USSR, same thing. Wait time was so brutal. So they noticed a very niche opening, and they jumped into that opening itself, meaning from day one they were not focusing so much on basically national things. They were more focusing on A, research and development, B, as in like missions that are focused on research and development rather than spying, and B, private players. So they jumped into that, and because their rockets were reliable and available for geostationary orbits, which mind you, which at that point in time is very expensive, very hard to do, and European Union has figured it out that how to do it reliably. It was like there was a very big slot opening, especially after the developments of proper solar panels and basically geostationary communication satellite. They just rushed into that market. There was a power vacuum, they rushed into it, and they printed money like there is no tomorrow. So it was the good days of them. And they had 252 successful launches so far, which is a very big number. If you remove SpaceX, it's still a very big number. So, and they had 96% success rate with Ariane 5. Ariane 5 was one of their most successful rocket. You can see this, like this started in 1980s, they were like Ariane 1, and by 1986 or 7, they started to jump into Ariane 2, and they developed Ariane 3 around 1984. So at peak time, they could literally had 2 rockets active, and one time there was 3 rockets active. Ariane 2, Ariane 3 and Ariane 4 were active. Now after 1990s, they jumped into Ariane 4. It was not long lived, but because they were focusing on Ariane 5. Ariane 5 literally came in around 1996 or 7, and this is their main workhorse. This is how they printed money. This is how they got their wings. Now this successfully started from 1996 till now, as in 2023. However, the replacement Ariane 6 supposed to have overlap exactly like this. There always should be overlap, because the early launches of rockets are always oops kind of launches. So you always want to have a scenario where you have a fallback. So for example, let's say on launch pad your rocket just goes achoo. You are like, okay, we're gonna remove your payload, put it into backup, and just launch it. It has been done. So it's one of those things where it's like, you always want some failover. So if anything that is critical, they will not even risk it on, let's say, Ariane 5. They'll be like, let's use Ariane 4 until our Ariane 5 is tested. That should have happened with 6. It did not. So far everything is good. This is like early 2005. Everything is good. Everything is handy. But things happened. The things happened was ISRO began to take some customers away. Like ISRO started to offer geostationary satellites and PSLV, Polar Satellite Launch Vehicle, that allowed a lot of low-cost launches. And GSLV, Geostationary Satellite Launch Vehicle, allowed geostationary options at lower cost. Both of them started to take some options away. So think of it this way: at their peak, they were like, we are getting hundreds of requests, we were selecting which we want to do, and then it slowly became, we're only getting 80 requests, more than enough, but you're only getting 80 requests. And then the Fire Nation attacked. So basically this happened, SpaceX. And after SpaceX, game changed. Why? Same way they noticed there was a gap for private players. Now SpaceX showed the world there is a gap for private launchers. The moment SpaceX launched a rocket, it changed the world. Because everybody till that point knew that private players are the majority satellite operator. That was a known thing. That was sorted. That was like, yeah, satellites, most of them are private. That's sorted. But rocket, that was like, whoa, can you actually make a rocket? Can you actually make a huge ass rocket? Not sounding rocket, a huge ass rocket that can put some heavy stuff in low Earth orbit? That was like, whoa. And SpaceX proved that. So that slowly started to change the game. And it became so bad in like around 2015 to 2020 zone, it became so bad that ESA had to subsidize that. Otherwise, Ariane 5 would have been retired very early on, because again, they would not get any contract. So subsidization has to be done. Now, be mindful, when I'm saying subsidization, is not like a very clear-cut thing. It's a bureaucracy and paperwork and all that. Some people specialize in that. You can look at their works into it. But the idea was like national projects were safe. Like James Webb will only be launched in Ariane 5. That was sorted. National launch assets, those will be launched in Ariane 5. That is sorted. But the private players, that started to just like, yeah, no. Heck, even Bangladesh launched their satellite using, Falcon 9. So that started to happen. And to make sure that this does not get just removed and replaced, because again, national projects now happen gap enough where they could literally have a scenario like, okay, one launch is this year, the next launch is 3 years from now. How the heck you going to keep the company alive? Subsidy. So they had to do subsidize to keep the cost low. So this happened. So how the heck this happened? Because ESA is not one of those things that you will think about, oh, poor people, or like, oh, they don't have money. That's not the thought that you have. And that's genuinely true. They genuinely had good amount of capital. So Arianespace, they were not updating themselves. That was their biggest problem. So they had a very good system. Like what they built was genuinely good for 1990s. They were like king of the hill. They knew what they wanted to do. They figured it out. They figured out a gap in the market. They even figured out how to have a tandem geostationary launch, which was like, whoa. People back in those days were like, are you kidding me? Like you literally have a payload fairing, it opens up, it drops one satellite, then it drops another. And both those satellites are like multi-ton satellites. People are like, what the hell? They were good. But that was 1990s. So they were completely nude for SpaceX environment. Basically, a world after Sputnik, so a world after SpaceX, they were like, nope, gone. So Ariane 6, basically that's their answer. But here's the deal, it's outdated before it came to market. So it's basically somebody from 1970 designed a rocket and they just put new engines. That design philosophy of this puppy, it's outdated. That's the problem. How outdated? Everybody knows it's outdated. So why I'm saying that it's outdated? Well, here's the three players that are right now active. SpaceX, big player. Rocket Lab, Electron Rocket, another small player, but is slowly becoming big. And then we have Dragonfly. So all of these have something important in them. What? They are built with wisdom. None of them have strap-on boosters. Strap-on boosters equal money go boom. That's the only realization that these people figured out very early on, is that strap-on, say no to strap-on. Strap-on boosters just only increases cost. It does not increase your efficiency. It does not reduces your cost. It just gives you delusion that it does. That's why ISRO does this. That's why ESA does this. And both of them wonder at the other end, is like, how SpaceX can do this? It's like, yeah, your design is outdated. This made sense in the early days of rocketry, when we were dealing with V2 rockets, when we were upgrading from V2, those sort of era, where fuels were literally diluted with water to make sure the chamber temperature stays low enough. That's the era where you could not have the oomph needed for like the modern designs like this. Nowadays, metallurgy is good enough. Nowadays, active basically cooling of the engines are good enough. Now you can push those engines to like new heights. So it makes more economical, structural, financial sense to just make a larger rocket and just yeet all this extra crap. And benefit of that eating all this thing is your part counts goes down. And be mindful, liquid rocket you can mass produce. You cannot mass produce solid boosters. Yes, you can do that. And yes, I know Army does that for boom boom sticks, but they have boom boom like money. You don't have boom boom like money. So solid booster motors, yeah, that's not as easy as you may think. And the bigger you make them, it's hilariously expensive. It goes like, oh, solid booster for this sort of kilonewton. Okay. This sort of mega newtons, like what? Price went up like what? That's the whole point. The design is bad. And fundamentally, it requires more steps to assemble. If you have one big thing, you have one train, done, go home, sweet dreams. One thing, done, go home, sweet dreams. This is like, do we need 2 strap-ons or do we need 4 strap-ons? And be mindful, strap-ons are solid boosters, meaning they are armed. The moment is made, they are armed. They are not like fuel. You cannot just keep mass producing it. You can look into other companies, small rocket launch companies, they keep mass producing it. You can't mass produce solid boosters because they are active. They have to be stored like boom boom sticks, and it's expensive. And how do I know that it's outdated? This is their upgrade design. This is Evolution 6. I'm not joking. They know this is so bad that it's like Evolution 2, we're going to fix this part. Evolution 3, we're going to fix this part. Evolution 4, we're going to fix it. At Evolution 6, I'm not joking. This is from their website itself. Liquid reusable booster. New liquid reusable booster with 3 Prometheus methane engine. Why the heck they're using hydrogen here? Like, I think we figured it out. Like in 1970, we had hydrogen brain damage. We figured it out that hydrogen does not have enough megajoule per liter to actually work. Space Shuttle had a huge tank. Like, there is only one private player that is going with hydrogen, and they actually have a good reason. First, they are using it for upper stage, wiser. Second, they have reusable metal heat shield that requires a coolant flow. Hydrogen is best for that. So they have a reason for it. What is your reason for this brain damage? It's like hydrogen is not a good fuel. If you really want that extra delta V, increase the oomph of your engine. If you cannot do that, put hydrogen on the top stage, not on the base stage. And they're like, yeah, we have to go to methane. Every private player figured it out. Either use rocket, basically RP1, kerosene basically, or use methane. Everybody figured it out. Except the company who has the most money. So this design, the philosophy of the design, I'm not talking about the parts. The design of the philosophy is just ancient. It's like somebody from 1970 literally Control-C, Control-V into modern world, and they're like, okay, what engines do we have? We have this engine. So instead of making the diameter bigger, which will allow them much more efficiency, what if we made it small? What if we only put 2 engines? It's like, how about you put 4? How about you put 9? How about that? No. What if we put some garbage in there? They're like, solid strap-on boosters. So fundamentally, it's one of those things. It's ironic how many times it has happened. It's not even like funny. It's like, really still making the same mistake and still wondering why the heck SpaceX or Rocket Lab, all these. And be mindful, once this puppy's Rocket Lab comes along, neutron rocket, yeah, this will not have that much options left. So it outdated before it's developed, and they are literally blackmailing ESA at this point in time. Same way NASA is being blackmailed by SLS. They're like, what can we do? Like, we have to subsidize this. We have to pay for this garbage. It's like, it's so outdated. They're like, yeah, upper liquid propulsion, we have to upgrade it. It's like, what did you design? Like, genuinely, what did you design? Like, why did your design literally looks like Soviet Union's design? It's like, why they're like, we can put more engines. Now we have more technology. And back in the first days, I understood it. It's like somebody said, hey, let's put 9 engines. People are like, dude, it's not reliable enough. We do not have electronics fast enough. Nowadays, it's like, bro, electronics works in slow motion. 1000 FPS slow motion. It's like, it's gonna see how engines are reacting. It's like, hey, chill, man. Hey, relax, bro. Oh, you need more oomph, more oomph. That's how fast modern electronics works. So philosophy is the reason why, even with all the money in the world, they still have poof performance. I love that fact. It's like, yeah, upgrade number 6. We actually do, and it looks like Falcon 9. It looks like a tiny Falcon 9. I'm like, you could have just used that design. So what we can expect in the future? Well, this is a very cautionary tale. Like, let that be very clear. This is a very cautionary tale. It's not about the money. Like, many times I have seen for ISRO, which is my own nation's space organization, will say, like, if ISRO had the SpaceX kind of money, SpaceX started for $100 million. And their original contracts, like, ISRO had more money than that. For first few years, ISRO had like far more money. They had far more capital. They had far more manpower. They had far more resources. If they had good philosophy, as in like design philosophy, they would have made a much better product. It's the same thing. Design and operational philosophy matters. For example, if you look at iPhone, why the heck iPhone feels so polished? Like it has the same display made by Samsung that is used in other Samsung phone. It has the same basically camera chip made by Sony used by other companies. So why the heck Apple? It's because of the philosophy. They spent time in polishing the damn thing. And same thing is happening here. ISRO, NASA, ESA, JAXA, all are stuck in that 1970s design where their engines were not powerful enough, computers were not vast enough, where they're like, what if we make a ultra skinny useless rocket and then we just strap stuff on? Like we just strap things on. It's like, what if you made it fat? Now, why did Falcon 9 is so skinny? Because SpaceX was poor in the industry. They had to transport it by road. So what is the first thing they do when they design a new rocket? Made it fat. Have you noticed how fat Starship is? Or look at neutron rocket from rocket. What is the biggest difference between electron and neutron? Neutron is fatter. Everybody figured out it's mathematics. You have a bigger diameter, everything becomes easier. But these companies are like, what if we make it tiny? And then garbage, and then complain to government that we are not getting enough money. So that's the whole point. Ariane is literally putting all their hopes in Ariane 7. Ariane 6 is useless. All it is a test platform for Ariane 7's technology. And hopefully by the time Ariane 7 is built, it will be modern. Modern simply meaning what SpaceX did in 2010 or 2015. That's when they had the first successful landing. So I hope that design is used. Philosophy, let that be very clear. Philosophy. That philosophy and reusability. So right now, all their hope is on this craft, the SUSE craft. It's much bigger than basically Orion. It's much more refined variant of what space shuttle could have been if the two parents actually made a proper love to each other rather than like, I just want mine big. It's like, that would have been really good. This is much better design. And it does have a launch abort system. So it won't be go pushing. So really good design. So that's their hope at this point. And it's a very cautionary tale. Let that be very clear. It's not about the engines you have. It's about the, like Merlin engine 1 was really not good. Heck, it did not even have active cooling. Merlin engine 1B, I think that's the first time they started to figure out, like you can write down which engine it was. Like it took them time to figure out how to have liquid cooling, like as in like propellant moving around to cool the engine. But because they were doing in a way where it was like philosophy was solid, they went from Falcon 1 to Falcon 5 design and they were like, Falcon 5 will be useless. Yeet that design, Falcon 9. And then rest is history. So that's the whole future point of it. Like strap-on equals dead. So this was my presentation on basically how the heck ESA lost its wing. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.